Hello. Here, this is a three-dimensional structure of a dextro-glucose. The black balls here represent the carbon atoms. The yellow balls here are the oxygen atoms. And the white balls here are the hydrogen atoms. And the white line in between them indicates the bonding. Now, here, this is an aldehyde group, CHO, and the carbon and oxygen are attached by a double bond. This is a linear chain of dextro-glucose, which means that corresponding to oxygen, this oxygen of aldehyde, firstly we have hydrogen, then an OH group, then we have an H group, and then again we have an H group. If I show you in this way here, it will be more clear. Alright. Okay. So, this is a CH2OH. Here is the second carbon. And this is the first chiral carbon. A chiral carbon is a carbon which has 4 different constituents attached to it. So here on the left hand side we have an H, and on the right hand side we have an OH. On the second chiral carbon, again on the left hand side we have an H, and on the right hand side we have an OH. On the third chiral carbon, here on the third chiral carbon, in the left hand side we have an OH attached, and on the right hand side we have an H. And here on the fourth chiral carbon, on the left hand side we have an H, and on the right hand side we have an OH. So this was the 3D structure of a linear dextro-glucose. Now, this is the 3-dimensional structure of a Levo-Glucose molecule. Here, this is again the aldehyde group. Right next to the aldehyde group, the carbon is having an H corresponding to oxygen. Then the carbon next is having an OH corresponding to oxygen. Then the carbon next is having an H, then an OH here. Now, there is a very subtle difference between the dextro-glucose and the Levo-Glucose, and that is the positioning of OH group and H group in this carbon here. This is actually the first chiral carbon, and the position of OH and H in this first chiral carbon is different in the dextro and the Levo-Glucose. In dextro-glucose, as we saw, the OH group was on the right hand side, and in the Levo-Glucose the OH group is on the left hand side. So this is the difference between the dextro-glucose and the Levo-Glucose. Now, this is another 3-dimensional structure of glucose. This is actually a ring form of glucose. It has 1, 2, 3, 4, 5, 6 carbon, 1, 2, 3, 4, 5, 6 oxygen, and 1 2 3 4 5 6 7 8 9 10 11 12 hydrogen atoms as in glucose. So this is a glucose molecule. Now this ring here, this is a Furanose ring. It has 5 atoms in it. The first one here at the top is an oxygen atom, and the rest 4 here, 1 2 3 and 4, these 4 atoms are carbon atoms. Now the first carbon atom here, this carbon atom is considered the first carbon atom and is known as anomeric carbon. If the OH group is attached below the plane of this ring, here the OH group is attached below the plane of the ring, then this is the alpha Furanose ring. This is the alpha Furanose ring. When the OH group is attached below the anomeric carbon or the first carbon. Here is the same Furanose ring but with a subtle change, and that is this. The anomeric carbon or the first carbon has OH group attached with it above the plane of the ring. This is the plane of the ring, and the OH group here is above the plane of the ring, and the hydrogen atom here is below the plane of the ring. So this kind of arrangement of OH and H in the first carbon or anomeric carbon of a ring is known as beta glucose. This is another three-dimensional structure in which glucose exists. See, 1 2 3 4 5 6 carbons, 1 2 3 4 5 6 oxygen, and 1 2 3 4 5 6 7 8 9 10 11 12 hydrogen. So this is a glucose molecule, and the structure is a Pyranose ring. This is a Pyranose ring. As you can see, this has 5 atoms present in the ring. The one here is the oxygen, and here 1 2 3 4 and 5, these 5 are the carbon atoms. Now see here, the first carbon here or the anomeric carbon has the OH group here, the OH group below the plane of the ring, and the H group is above the plane of the ring. So this is alpha Pyranose. This is alpha Pyranose. Now here, as you can notice, the anomeric carbon has OH group above the plane of the ring, and the H group is below the plane of the ring. So this kind of arrangement is known as beta Pyranose.